Alright, so on the last page of your packet is where you'll find the assignment, or at least tonight's assignment that goes with it. These are the notes we're going to be doing the next couple days. The assignment is out of your book. Alright, the assignment is out of your book. If you want to bring that book in tomorrow, you don't need it. So we can start crossing that off. One more obligation to do. Feel free to do that. People at home, you should be getting a message on when you need to bring it in, but I will share that with you tomorrow as well. Google Classroom, 3-5. And yeah, well, this is it. So there we go. Okay, so sequences and series, 8.1. Start with what they are. An infinite sequence is a function whose domain is the set of positive integers. Each value, a to the 1, a to the 2, dot, 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 a to the n is considered a term of the sequence. If the domain of the function consists of the first n positive integers only, then the sequence is considered finite. Good. Problem type 1, writing the first 4 terms of a sequence. Writing the first 4 terms of the sequence, a to the n equals 3n minus 2. Now it looks like slope-intercept because it is a lot like slope-intercept. Here's the difference. Unlike slope-intercept, we do not consider -2 our first value. Instead, we plug in 1 to get our first value. So when I plug that in, a to the 1 equals 3 times 1 minus 2 equals 1. All right? So that may be the part you want to jot down, the a to the 1 part. Equals 3 times 1, which is 3 minus 2 is 1. All right. From there, you have choices. You can continue plugging in 1, 2, 3, 4, or you can use the coefficient of n to represent your increase or decrease. All right. Either way, a to the 2 would be 4, a to the 3 would be 7, and a to the 4 would be 10. Good. So you'll notice each time the number goes up 3, the same as the coefficient. All right, what if it's not linear? You have 2 choices, either A, to plug in for the first value, or B, continue this or look for patterns. For example, a to the n equals 3 plus -1 to the n. All right, when I plug in 1, -1 to the 1 is -1, 3 plus -1 is 2. When I plug in 2, -1 squared is 1, 3 plus 1 is 4. When I plug in 3, it goes back to being negative, 3 plus -1 is 2. When it goes to 4, it goes back to positive, 3 plus 1 is 4. That will continue forever and ever. So basically, God bless, you may be asked what's a to the 17th. Well, that's an odd number. So all the odd numbers have a value of what? 2. If they ask for a to the 500, rather than plugging in everything where you can, realize it's easy. Okay? So it's your choice on what you do. Again, for homework tonight, I don't need to see any work. Just need to see answers. All you have to do is post your answers, much like the subplans that were out yesterday that are up and due on Monday. Okay? Good? Grab yourself a graphing calculator if you do not have one of your own, please. All right. All right. Now, you are certainly going to be able to use a graphing calculator. The advantage of graphing calculators, you can do all those operations simultaneously. The one thing is you have to remember how to use a graphing calculator. So you can't come up and say, how do I do this again for the quiz next week? You have one quiz next week before senior service day and all that, and senior cut day. And then you'll have quiz the following week, and then we're done. Start reviewing for the final exam, for people taking the final exam. All right, so using the graphing calculator, we plug in 1 to n into L1. 1 to n means the terms. So if they ask for the first 4 terms, you would plug in 1, 2, 3, 4. You then plug in the rule into L2, replacing the letter n with L1. All right, so this is what I'm looking at. -1 to the n over 2n minus 1. To do that, the first button you press is step. Is that button there. And we are going to edit the list, so we just have to hit number 1. All right. All right. So then you would put in 1, 2, 3, 4. All right. Good. Now, when you put it into a list, that is the top of a list. This is not the top of the list. When you're at the top of the list, the actual list is being bolded or highlighted. You clear it out. So you hit clear and then enter. All right. So you go up there, you hit clear and enter. Now, the calculator automatically puts you down there. That is not where we want to be. We want to be back up there when you do this. All right. So it says a to the n equals -1 to the n. So I go parentheses because it has it, -1. N's an exponent, so I hit the exponent button, which is below clear. And instead of n, you hit second and 1. That's how you put a list into the graphing calculator. You hit second and the number. All right, that's then being divided by, so you hit divided by. Whenever you have a rational expression, you take the denominator and put that in parentheses. 2, n again would be 1, so second 1, 2L1. -1. All right, so that's how you put it in. You then hit enter, and it will shoot out all the numbers for you. All right, when you're doing this for homework, I would expect you to know, well, let's see, -1 is -1, but I would expect you to know that 0.33333 is what? 1 over 3. All right, -0.2 is 1/5. That is 1/7, but for the time being, if you want to put it in as a decimal, it's fine. The reason being is, if we look at it in terms of patterns, we'd have -1, 1/3, -1/5, and positive 1/7. If I take the -1 and put it over 1, you'll notice the denominator is going up how much each time? 2. Well, that's consistent with the 2. And then the -1 in the end, we're going to talk about in a little bit in terms of alternating between negative and positive. And you can just write down your answers as well. Good? All right. Next up. Given the first 2 terms of a sequence, find the expression. If it is linear, which means mn plus b, the difference between this and slope-intercept is find m, and then find your adjustment needed for your first term. This is b. All right? You're going to find m and then find your adjustment needed for your first term. This is b. All right? So if I look at the first one, how much is it going up each time? 4. So I know it's 4n. You then look at whatever your m is, your coefficient, and compare it to your first term. And figure out how much you have to add or subtract to your m to get that first term. So I'm going from 4 down to 1. How do I get from 4 down to 1? Subtract 3. So you would just do 4n minus 3. And then you can check to see if it works. My second term, if this was 2, 4 times 2 is 8, 8 minus 3 is 5. Third term and so forth, and you go from there. So use that line of thinking. Take about 22 seconds to do the next one. Everybody good with 2n plus 1? Okay. When it's not linear, see how it relates to the following: n squared or n cubed, or x to the n, where x is a constant. All right? And this is what I mean. This is either going on in your head or on paper. I take my sequence, which is 2, 5, 10, 17. And then I compare it to the different functions. If I compare it to n squared, if I square 1, I get 1. If I square 2, I get 4. If I square 3, I have 9. If I square 4, I get 16. Is there a definite connection between our original sequence and n squared? Yeah. Each term is how much more than n squared? One more. So my final answer would be n squared plus 1. All right, n squared plus 1. I got you.
I like this.
Good. All right, now I look at my next one, and this should be a comma, not a period. I apologize. So my sequence would be 2, -9, 28, -65, and 126. Now, the first thing you hopefully notice is there are alternating signs. So the sign alternates. Between when this occurs, -1 to the n in some format must be involved. You got me? So if I'm looking at a problem, all right, if I'm looking at a problem and I see the signs are alternating, I know my solution starts with -1 to the n. And you put it inside parentheses. All right. Now, n squared, 1, 4, 9, 16, 25. Is there any recognizable patterns between the n squared and the sequence? No, so perhaps I try n cubed. 1, 8, 27, 64, 125. Ignoring the positives and negatives, is there a definite relationship between the sequence and n cubed? Yes, it's how much more each time? 1. So that's going to be n cubed plus 1. Here's the last thing you got to check when the sign alternates. When I plug in 1, -1 to the 1 would be a negative, right? Which would make that, instead of a +2, a -2. When that occurs, when your first number is the wrong sign, all you have to do is go up to n and either put +1 or -1 for your exponent. So thus, the first term would now make that 2, which would turn that into a positive. If it's the right sign, you leave it as n. Okay? All right. Now we're going to skip the next part. We're going down to here, some notation. All right, the other part we'll come back to tomorrow, defining sequences. All right, factorial notation. N factorial is defined as n with the exclamation point is 1 times 2 times 3 times ... times n. All you're doing is taking n and multiplying it by all integers greater than 0 but less than n. N factorial means you multiply n by all integers greater than 0 and less than n. So for example, if you had 7 factorial, the result would be 7 times 6 times 5 times 4 times 3 times 2. Your choice if you want to write the 1 or not. Because multiplying by 1 is going to make it stay exactly the same. In the graphing calculator, you hit the math button. You go over to the probability menu and you hit 4. So for example, if I want to do 7 factorial, 7, all right, 7. Here's the math button right there underneath alpha. I go over to the PRB menu, and you'll see next to number 4 the factorial symbol. So 7 factorial, and then you hit enter. And you see the answer is 5,000. Okay? All right, now, find the first 4 terms of the following sequences. So the one on the left, a to the n equals 2 to the n over n factorial. A to the 1 would equal 2 to the 1 over 1 factorial. 2 to the 1 is, of course, 2. 1 factorial would be 1. 2 divided by 1 is 2. A to the 2, the second term, would be 2 squared over 2 factorial. 2 squared is 4. 2 factorial is 2 times 1. 2 times 1 is, of course, 2. 4 divided by 2 is 2. A to the 3. 2 to the third over 3 factorial. 2 to the third is 8. 3 factorial is 3 times 2 times 1, which is 6. And I would expect you to reduce that down or simplify. And then finally, a to the 4th is 2 to the 4th over 4 factorial. 2 to the 4th is 16. 4 factorial is 24. 4 times 3 is 12. 12 times 2 is 24. And that reduces down to 2/3. All right? Give the one next to it a whirl, please. A to the n equals 3 to the n plus 1. 3 to the n is the only exponent, plus 1 over n factorial. Good? All right, last thing of the day, simplifying factorials. You have choices. 8 factorial over 2 factorial times 6 factorial. Choice number 1 is writing everything out. So 8 times 7 times 6 times 5 times 4 times 3 times 2. Your choice if you want to write the 1 or not. The bottom, 2 factorial is just 2. And then 6 factorial would be 6 times 5 times 4 times 3 times 2. What does everything from the 6's to the 2's do? Cancels out. And you would have 8 times 7, which is 56, and 56 divided by 2 is 28. Another way to do it, all right, is just write the ones that aren't part of this. In other words, 8 factorial would be 8 times 7 times 6 factorial. And then on the bottom, 2 factorial is just 2 times 6 factorial. What do the 6 factorials do to each other? Cancel out. Leaving you with 8 times 7, which is 56. 56 divided by 2 is 28. All right? Any questions? All right. There are currently 2 homework assignments up in classwork. One is due Sunday, one is due Monday. All right? The one that is due Sunday that is in the back of this, and up in Google Classroom. All right? So it's under 8.1, homework 1. All right? 8.1, homework 1. You have to do 8 to 26 even. You have to do 8 through 26 even. You have to do 34 to 52 even only. And then the last batch is 64 to 76 even. Answers only. I don't need to see any work. Answers only on a separate piece of paper, please. Don't try to fit it on there because it's a pain to read. So answers only. All right? That's what's due Sunday at midnight. So 8 to 26 even, 34 to 52 even, 64 to 76 even. Those of you trying to get eligible to be exempt from the quarterly, this is worth 20 points. Double homework assignment. Well, this one's 20. The sub-plans are going to be 10. We'll walk through that in a second. So, if you were absent for some reason yesterday, all right, this is what it looks like. The sub-plans May 19th. All you have to do is find the next 3 terms in each sequence.
Oh, that's cheap.
Yeah. So, for example, in number 1, we're multiplying by -3 each time. So there you go. If you need a hard copy of it, it's right there. Now what's up? Yeah, right there, that one. All right? And that is due Monday. Again, answers only. All right?